So today we're going to be moving on to our next chapter, and we're going to be talking about radicals. So involved in this chapter are going to be radical expressions and radical equations. So we're first going to start by talking about the parts of a radical. So the nth root of a number a can be written as the radical expression, the nth root of a. The root of a is right there. So when we look at this, our n is going to be called the index. Inside of our radical is going to be called the radicand. And then this is called our radical. And then if there's no index, so if there's no number right here, we're going to assume that n equals 2. If a radical has more than one root, the radical sign indicates only the principal or positive root. So we're going to list our perfect squares. We're going to list the first 12 perfect squares. And a perfect square is you take a whole number and multiply it by itself. So we have 1 times 1, which gives us 1. 2 times 2, which is 4. 3 times 3, 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9, 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 finally is 144. So these are called our perfect squares. So we take a number and multiplying it by itself. And then if we do the reverse and have perfect square roots, we're going to backtrack that. So the square root of 16, perfect square is going to be 4, because 4 times 4 gives us 16. Looking at number 2, I have 2 outside of my radical, and then inside the radical I have 121. And I know 121 is a perfect radical, so I'm going to take that 2 and multiply it by the square root of 121, which is going to be 11. So this is multiplied by 11. And 2 times 11 is going to give us 22. Now we're going to move on to simplifying non-perfect square roots. So there's going to be 3 steps for simplifying non-perfect square roots. Step 1, we want to find the largest perfect square that the radicand is divisible by and break down the radical using this number. So if we look at number 5, I have the square root of 32, or radical 32. So I need to break down this 32 and see what it's divisible by. And I want to see what the largest perfect square that this is divisible by. So I know that 32 is divisible by 16. You can do 16 times 2 equals 32. And 16 is a perfect square. So I'm going to do radical 16 times radical 2. So we're just simplifying this radical 32 to radical 16 times radical 2. These are the same thing. So now I'm going to keep going. I know that I can complete the square root of 16 because it is a perfect square. So the square root of 16 is going to give me 4. And then I have times radical 2. 2 is not a perfect square, and I don't want to deal with a messy decimal because we're just simplifying. So I'm going to leave that 2 under the radical. So I'm going to be left with 4 times radical 2. Because these are multiplied, and 4 is now outside of my radical because I did the square root of 16, and you can't multiply if there's something outside the radical and something inside. So we're leaving the 2 inside the radical, 4 staying outside. So square root of 32 simplified is going to be 4 times radical 2. Looking at number 6, I have the square root of 180. So I need to look for factors of 180, and I want the largest perfect square. Okay, so looking at this, I know that 180 is divisible by 36. So I'm going to break this down to square root of 36 times square root of 5. Then I'm going to take the square root of the perfect square, so that's this one here, and take it out of my radical because the square root of 36 is just 6. And then I'm going to leave my leftover 5 under my radical symbol. So I'm going to have 6 radical 5. And that's going to be my final simplified answer.